Warm welcome to one and all. Back in 1989, Fred Davis, in his paper titled Perceived Usefulness, Perceived Ease of Use, and User Acceptance of Information Technology, he presented about what factors influences the user acceptance into the advancement in information technology. He says, usefulness and the use of tools comes with advancement in technology acceptance model. This paper has been an inspiration and motivation for me to work towards open source and making use of different tools that we could benefit from. Ever since this paper, this research work, there has been many other advancements. For example, there are different researchers who have come across what factors could influence the advancement in IT industry, be it the literature, be it the technology itself, be it the individuals, be it the different proposals, and so on. In my talk today, Actions in the Wild, Usability and Ease of Use of Open Source Security Tools, I present to you about the key factors, the usability and ease of use. Usability, consider this as a degree of freedom where you can gauge what usefulness could it bring in improving your job performance. Ease of use, on the other hand, will enable you to understand how seamless could certain new technology be integrated into your work environment without needing much changes and be a real support. With this, I introduce myself. My name is Rohan Krishnamurthy. I am a cybersecurity engineer at ZF Group for development of technology and infrastructure. I am proudly a committer member at the Eclipse Tractus-X project under the special interest group focusing on security. Besides this, I'm also a special interest group member for First.org, working towards exploit prediction scoring system, and as well as with the Open Chain project, working for the working group of security tooling. In the talk today, we will go through a short introduction about the Tractus-X project itself, but more in detail about the security activities across the SDLC, a myth buster based upon my experience. It's my personal opinion, but I have it. And there are best practices anchored by different GitHub actions, and hence the name Actions in the Wild. And we will go through how CVEs and CVSS scores impact on understanding what vulnerabilities should be considered and how the prioritization is done. And then there will be a bonus slide, of course, following with the talk related to APSS. So Eclipse Tractus-X. So with the QR code, you can go to the homepage of it. There's a landing page. So Eclipse Tractus-X is an open reference implementation of Catena-X Automotive Network. It's first of its kind, and it's one of its kind. It's a huge project. It's a decentral platform which allows multiple automotive industries to exchange data in a secure way. It's housing of around 60 repositories with different product lines, with different components and their implementations. And there are around 250 contributors and 40 committers working towards its betterment. And I'm proud to be one of the committers over there. As you can imagine, within such a big project, at the time of the release, you will have many milestones to fulfill. There are quality gate checks, which involves multiple iterations. And for such reason, we have set up different release guidelines, wherein every committer, every developer needs to adhere to. And as a member of release guidelines, or as a chapters of release guidelines, we look at different aspects, be it your complete folder structure, be it the release notes, be it the security.md files, be it the contributing.md files, or the code of conduct, and so on. But for this talk today, we will definitely look at the DRG number 8, the chapter 8 that goes for security. And within security, right now, as of this date, if you open up the Tractus-X GitHub repository, you will find 5 different tools looking after different activities. One of them is the SAST that looks after the static code analysis, which is done by the native GitHub tool that's called CodeQl. In the second chapter, we'll talk about the infrastructure as code scanning available by Kix. In the secret scanning, looking for different leaked credentials, we use Trufflehog as a tool. For the container-based scanning, we use Trivy. And for the composition analysis, we use Dependabot. So this is available as native from GitHub as well. Now, coming to the point of Mythbuster, as I promised. So this is based on my personal work. You can take me for granted, but based upon your experience, you can make sure whether this Mythbuster holds true in your case as well. The statement that goes, commercial tools would yield a secure and a safer product than any other open source tools. It definitely comes with different features, auto-triaging with lesser false positives, as they claim. But my personal opinion is that that is not 100% true. It might be true for features, auto-triaging, beautiful dashboards, allows you to look at what are the vulnerabilities that you have come across since the last 6 months, 1 year. It's great for looking at the history. Of course, it's also useful when triaging based upon the CVSS scores. But my personal opinion, open source tools can also do all those things that has been done by commercial tools. And how do I say this? What is the stage? On what background do I commit this statement? Is followed up with the CVSS scores. So CVSS scores are the common vulnerability scoring system. I want you to pay attention to the very first two categories. So in general, the range has different categories. For example, ranging. So the first column here, as you see, very high and high, the score of 4 and 5, has a different range of CVSS score on the very last column, that is 9 to 10 and 7 to 9. So the CVSS score version 3 range is the standard range provided by NVD. Tool A here is a commercial tool. I will keep it anonymous. This was one of the tools that we had used in our project. It's a commercial tool, and if you observe closely, for the very high, it's between 8 and 10, whereas the official NVD range is the range between 9 and 10. And for the high category of vulnerabilities, we have a range between 6 and 8 for the commercial tool, whereas the NVD score says it's between 7 and 9. So there are a few aspects you would want to look at how the scoring is done and why the scoring is based upon whether NVD is the right one, whether the individual commercial tools that they promise to fulfill major vulnerabilities that need to be fixed are the ones that you need to look at. For this, let's pay closer attention to what the commercial solution is providing and what the open source tool is providing. On the third column, if you see here the CodeQl range, I have it right now right next to this, the CVSS scores provided by NVD. It matches the range. On the other side here, commercial, you see a range between 6 to 8 is the range that is provided for the high set of vulnerabilities. Now, within Tractus-X project, we have a set of policies that we have defined. For security policy, for example, we want to adhere or we want to address all the vulnerabilities that are between high and critical. So the medium findings are the ones that you can, of course, look at, but it's not a must for every releases. So we want to concentrate on every high findings and very high findings to be definitely addressed. When I say addressed, they need not be definitely mitigated, but if there is a false positive, of course, it's then discarded. But it must be addressed. Now, when I looked at all these repositories by performing the scans using a commercial tool as well as on the open source tool from CodeQl, of course, in the blind side, it's for sure that commercial tools will give a different number because it covers a different range, and then there are different set of vulnerabilities that are covered. And this gives you a perception saying that, hey, commercial tool is giving me 50 vulnerabilities, whereas on the open source CodeQl is giving me only 25 vulnerabilities. But having said that, if you pay attention to this particular range, which normally whenever we develop something, where we are generally focusing on what is the CVSS score and whether a particular vulnerability falls under high or very high, and then we start to fix it. So with this, I want to make sure that whether you are looking at a commercial tool or whether you're looking at focusing on the open source tool, make sure that you have this set of CVSS scores in place, and you can address all the vulnerabilities accordingly. Now, there are certain benefits and as well as one of the drawbacks which I came across while working on the open source CodeQl tool. On the left side, as you see, it's a log injection attack within the same source and SIG, and it has been provided with multiple iterations. So if the CodeQl says there are 8 vulnerabilities or if there are 20 vulnerabilities, it does not mean that all of them are unique to each other. So there are instances like this where log injection attack has been redundant across different line locations. So that was one of the drawbacks which I found was, let's say, not required. You are within the source and sink, and it must be something like maybe 1 or 2 log injection attacks could be useful. On the right side, you see a vulnerability that was found was server-side request forgery attack. So within the Tractus-X, since it being a decentral nature, we generally have scenarios where we acquire the URLs at the runtime to offer 2 different services. CodeQl in this case was very useful because it was able to come to that location where you are fetching a particular URL. Although it is not something that is critical to the input sanitization because we already have this URL acquired at the runtime, but it was brave enough to find out this issue. Now coming back to the main table again. So here now I'm focusing on the container-based scanning image based on the Trivy range. Or the Trivy tool against the NVD source. So here, if you observe, the scores are very much exact with the NVD range. So does it mean that all the vulnerabilities have the same kind of criticalities? Does it hold? As a matter of fact, it is not. So I have two examples for you from my experience. So one being the CVE 2022 for 40897. It was marked as high by Trivy, but if you go to the NVD scores, it's marked as medium. Now, if you, as a product developer, whether you want to consider a vulnerability that is marked as medium by NVD, or why does the Trivy says it's a vulnerability that is marked as high? It's a question of argument, right? Because you have a security policies that says we want to only look at vulnerabilities that are marked at high and above. So I can simply ignore because this CVE falls under medium category for NVD. Second example, Trivy, where you have a particular CVE scores which are not still assigned with a particular CVSS score from NVD, Trivy marks them as high, as a best practice. So this is on one side, it's a great sign because whenever we don't have a particular CVSS scores assigned for a CVE, Trivy takes this into action and because it considers vendors' precedence over the NVD scores. Let's look at this particular CVE as I showed above for the 40897 in detail. So what is this CVE about? So whenever we look at a particular CVE with a particular ID, we look at first at the description about what is the CVE is all about. So it's a Python package of setup tools, and it says it's vulnerable to regular expression of denial of service attack. Now, when we go through and read through the description, it says all the versions of the setup tools that are 65.5.0 and below are vulnerable to this particular attack. And the ones patched version that is available, or the safest version that is available, is 65.5.1. Now, in this case, as I showed above in the previous slides, that Trivy reported this vulnerability as a high score. So this high score comes from the GitHub Security Advisory database and not from the National Vulnerability Database. So what does the score from NVD? It says it's 5.9. So 5.9 and 7.5, if you look at the margin is quite big. In the very first slide, if you remember, when I showed you how the commercial tool provides a business strategy or a marketing gimmick by populating as many vulnerabilities as they can with the window of CVSS scores, how they play. Considering that into account, this gap of 5.9 to 7.5 is quite huge. Now, to address this, what you could do is you can already by yourself, have a breakdown of what this NVD scores actually comprises of and what actually influences a particular score. So NVD or be it the GitHub Security Advisory Database score, you can always have a look at the CVSS score and how it breaks down individually. So if you concentrate on the abbreviations on the top line, for AV, which means attack vector, for AC, it's the attack complexity. For PR, it's the privileges required. For UI, it's the user interaction. For S, it is the scope. And CIA, that is followed by confidentiality, integrity, and availability. Now, you can play around by yourself whether in your project, within the particular product for a module, whether you consider this applicable notions that are provided by NVD or the GitHub advisory database fits into your project in the way it is supposed to be. So here, if you observe, so the attack complexity which is describing says more severe for the least complex attacks. So NVD says it's a very complex attack. It's very hard to do. That's why it's a high vulnerability. Whereas on the GitHub it says the complex is too high. So having a risk is too low, and that's why it provides low as the solution. And this leads to a different score of 7.5 and 5.9. So the decision must be taken by the product developer itself, because they understands how the communication is done and what is the module actually doing, and whether this breakdown actually fits to what their instances are, and whether you want to go for the score based on the NVD or the advisory, or whether you want to have a bigger breakdown of it. And you can do this by looking at the CVSS score calculator by yourself. So if you Google up for CVSS score calculator, it will come to this landing page where it allows you to play around with your own way of identifying whether the exploitability matrix holds good for yourself. So in this case, as for the short with the previous example, so this is how it looks. And based upon your experience, you can play around with the attack vector says, OK, I'm not in the same network. I'm at a remote location. So if you're living in a remote location, whether this attack is feasible or not. When it comes to your impact metrics, when you're looking at the CIA, where you say, OK, I have some confidential information there. I do not want to keep it to none, but I would keep it to rather low and want to keep it safe for myself, and then see how the scores actually behaves. So this will give you a good understanding of what the CVE is all about, and whether you want to make changes to your version upgrade as well. So this acts as a very good informative system for yourself to be educated, to understand what a particular CVSS score is, how it is pretending to it to be, and with this notion of understanding whether you are looking at NVIDIA's database or any other database for that matter, you can make the decision and provide your own justification if you are ignoring a particular CVE that will not going to be fixed, or that whether you are going to fix it so that you want to keep it safer for yourself. The next topic is secret scanning, which I also found it quite interesting, because generally when we say secret scanning, we generally talk about regular passwords, admin, QWERTY, password 123, test 123, and so on. But that is not the only things that we need to consider. In fact, I have some good breakdown for 3 different tools here, which I have tested it. And for the Tractus-X, the chosen one is a Trufflehawk. I'll come to that point why this was chosen. Secret scanning, which is the native GitHub secret scanning tool, does most of the things by itself. For example, if you have a test credentials like test123, password123, QWERTY, and so on. So this tool is very much sufficient enough if you are not handling any of the API keys or GitHub tokens. Git leaks, on the other hand, if your project is having a complex structure of using Docker images, or if you are in the cloud storage, if you are trying to access any API keys, Git leaks, unfortunately, is not up to the state of the art to look at all the credentials that are leaked over there. Trufflehawk, on the other side, is capable enough to do all those things, except that very small things which I mentioned about. Password 123 is something Trufflehawk cannot detect because the working pattern is totally different. Whereas if you ask me about the bearer tokens or the GitHub tokens, Trufflehawk, upon identifying those tokens, it actually looks for validating those tokens. That means it looks at what is the secret about, whether this secret can be validated under the categories like GitHub tokens and so on. Then it is not something that is a leak, but it is actually used in your project. So it actually allows you to have lesser false positives when in comparison with the secret scanning or the Git leaks if you want to try out. So that is my experience, and feel free to try out all these open source tools, because secret scanning is not just about passwords and some credentials that is used in your project. So now come to the point of bonus slide. So the bonus slide is about exploit prediction scoring system. So earlier we talked about common vulnerability scoring system. Now I'm going to talk a little bit about the exploit prediction scoring system. So the QR code here, it takes you to the paper that is talking about how the exploit prediction scoring system works. So this basically talking about, it's a data-driven approach. It's not a human-made scores. So the data comes from different CVEs that are populated, and it gives a probability score of between 0 and 1. So the higher the score, the chances of that CVE to be exploited is high. But what is the prediction? So having a probability of high means that with a prediction score of, with a probability score, let's say 0.85, for example, it says a certain CVE that has been identified could get exploited. Now, what is the prediction of this particular scoring system is that this prediction comes for the next 30 days. So if you are in this phase where you're looking at a particular CVE, so this prediction scoring system predicts that whether this CVE can get exploited in the next 30 days. That means it is of highest priority for you. I looked at what is the EPS score for the CVE that we earlier talked about, the 40897. So down on the yellow side, it says 0.53%, and with a percentile of 77. So 0.53% is that in the next 30 days, if this vulnerability stays in your project, it's a 50-50% chance that the vulnerability could get exploited. And what is the percentile? It's a 77 percentile. That means it's on the higher range of other vulnerabilities that are alongside this particular CVE that has been identified within your project. So now it's up to you to understand. You have 3 different matrices right now in front of you. One, the medium score from NVD, high score from GSS, and now the EPSS score of 0.53, which is 50-50. So now you are having a different slab. So this way, you can always interpret on how the CVE could be affected into your project, whether a scoring system of high or very high could lead could lead you or could influence you to fix it at the very instance, or is this something that you can play back and forth to understand whether this needs a fix or whether this needs a fix with respect to upgrading to a particular version and so on? Just recently, with the GitHub Secret Advisory Database, I think last couple of weeks ago, they announced that EPSC score is also now integrated along with the CVEs. So the CVE that I already showed you above with the EPSC score of 0.5 through, so this is now available in the GitHub Security Advisory Database as well. So they have already integrated this. So with this, I hope I tried to prove my point of how you can influence the usefulness of a particular technology into the advancement of IT, and how ease of use of a particular tool will help you to seamlessly integrate a newer technology into your workflow, into the workflows. With this, I would like to conclude my talk. Thank you. Any questions, please? All right, then. Thank you.